So here we have a picture. I got this from, I just kind of screenshot it from Desmos of y equals, well actually here it is right here. Y equals sine x squared. And then I, adjusted the window so that we could get an idea of what's going on. So now if we want to estimate, we want to use the midpoint rule to estimate the integral from 0 to 0.5 of sine of x squared dx using n equals 8. That means we want to find m sub 8, right? And the idea is that m sub 8 will in fact be approximately this integral of sine x squared dx. Now, this integral right here of sine x squared dx, sine of x squared dx, does not have a closed form. So if you try integration by parts, you will fail. If you try trig substitution, if whatever you try, u substitution, all of that will fail. This is an integral which does not have a closed form. Okay, the antiderivative of sine x squared doesn't have a closed form. So if you need to integrate this, the best you can do is try to give an approximation. Now, I just wanted to show you kind of what this meant. What does it mean to discuss M8? Well, since we're going to 0.5, first of all, this is 0.5 right here. So the area that we're trying to approximate is the area from 0, maybe I should zoom in here. It's this area right here, right? And then including that all the way up to there. So that's the area that we're trying to approximate. And how we're going to do it is we're going to find our rectangles, right? So I need to split this interval from 0 to 0.5. This interval needs to be split into 8 subintervals because they told us that n is equal to 8. So how am I going to do that? How long will each subinterval be? Well, the whole interval is 0.5 or 1/2. So each subinterval needs to be an eighth of that. Okay, or 1/16. So how much is 0.5 divided by 8? How much is 0.5 divided by 8?
0.0625.
0.0625. All right, good. So for sure, this is splitting it in half, 0.25, right? And then 2, 4, 5, so it'd be 2.5. Okay, here. And then I'm just kind of estimating at this point. Okay, then here, and then here and here.
It's 8:30.
It's 20:30.
Okay, and so now that we have our rectangles, we would need to find the midpoint of each rectangle. So, and then evaluate it. So if this is, so x1 bar is right here, and the height is so close to 0, it barely is noticeable. Now the midpoint here, we're just estimating that x2 bar. So f of x2 bar is over here, right? And we're adding this height to our approximation. And then this is x3 bar. It looks like here's f of x3 bar. Okay. So we're adding this. So notice that it's definitely going to be an approximation because, for example, because we are getting, we're including too much on one hand, and on the other hand, we're not including enough. So like this right here is included in our estimation, but we didn't include this. Do you see how we're underestimating by not including this green part, right? Because that green part is underneath the entire the graph. Because remember, what we're trying to estimate is this pink area, which is the area underneath the graph. So by using this little rectangle that we've chosen here, by using this rectangle, we're getting too much over here with the blue and not enough over here because we're missing that green, you see? So that's why it truly is an approximation in this case. And so, and again, we can keep on doing this. You find the midpoint, you create a rectangle, right, that has the width of your subinterval, and the height is determined by the value of the function at that midpoint, right? So that's why it's called the midpoint rule, because you're using the midpoint of the subinterval to determine the height of your rectangle, okay? And then now let's see here again, and we can do this as much as we want. Interesting questions are, what is the midpoint rule? Can you draw an example where the midpoint rule is definitely going to give you an overestimation? Can you draw a function where the midpoint rule, for whatever n you choose, will give you an underestimation? Can you draw a function where the midpoint rule will give you an overestimation? Right? So this, thinking about questions like that will help you to kind of understand the midpoint rule. Okay, believe it or not, so this is just a sketch of what the computations will be doing. Believe it or not, this right here, this computation is very helpful. This is our delta x, because remember, delta x is equal to b minus a over n. So in our case, b is 0.5. So let's go ahead and, move to the next page and formalize this, right? So we want to, our goal is to compute M8, okay? And we know that we've got our formula over here. Let me perhaps zoom in over here. In order to use this formula, we need to know N, we need to know A, we need to know B, and we need to know our X sub I bar, okay? And so before we can do that, we also need to know F. So let's go ahead and write this stuff down. Okay, so we know that N is equal to 8 because that's given to us in the problem. F of X is going to be sine of X squared. That's also given in the problem because they're telling us to approximate the integral of sine of X squared dx. Okay, A is 0, B is 0.5. Again, that's in the setup of the problem. And since we know N, A, and B, we can compute delta X. Delta X is supposed to be B minus A over N. So that'll be 0.5 minus 0 over 8. And on the last page, we computed that and found it to be 0.0625. So for our formula, M8 equals delta X times the sum, I equals 1 to 8, F of Xi bar. Okay, so notice that I replaced this N with 8, right? Everywhere I see an N, I replace it with 8. Now I'm going to be able to replace delta X with this 0.0625. So I can write this as equal to 0.0625 times the sum, I equals 1 to 8, F of Xi bar. Now, this means F of X1 bar plus F of X2 bar plus F of X3 bar plus ... all the way up to F of X7 bar plus F of X8 bar. Right, and then all of this times 0.0625. This is our M8. So remember sigma notation. This is what the sigma notation means. It means to add up these terms, F of Xi bar, starting with I equals 1 and stopping with I equals 8. So the next thing we need to do is we need to figure out what is Xi bar and then what is F of Xi bar. So I'm actually going to make a little chart here. and then here's I. Okay. So at this point, it's really handy. At this point, it's really handy to have either a Desmos open or your trig calculator. Some way to compute these values, because you're going to need to compute your function. You're going to need to evaluate your function at these midpoints. So now's the perfect time to have a calculator. All right. So when x equals 1, how do we find x1 bar? What is x1 bar equal to? Well, it's going to be equal to, remember the formula that we have is that xi bar is equal to xi plus I times delta x. And xi is the ith endpoint. Okay, so for us to get the first endpoint, so here's x1, here's x2, right? x0 is here, x3. The midpoints have the bars, and the endpoints don't have the bars. Okay. So to get the first midpoint, if we know that the length of each interval is 0.0625, then the first endpoint is going to be 0.0625, right? So it's like if you're starting at 0 and you're stopping at 0.5, and each subinterval has the same width, then your first endpoint is going to be 0.0625. I think I've messed up on my formula here for xi bar. Let me go back and make sure that I have the correct formula here. So xi bar, the only thing we know about xi bar is that it is the midpoint. It is equal to the midpoint of the first subinterval. So this is x1 bar is going to be the midpoint of the first subinterval. And now what is the first subinterval? The first subinterval goes from 0 to 0.0625. So from 0 to 0.0625. This is the first subinterval. So what's the midpoint of this? Well, we just need to take 0.0625 and divide it by 2. So 0.0625 divided by 2 is going to be
0.03125.
Okay, so it's going to be 0.03125. And now, in order to find f of, I think I can do this a little better here. So here's what we have. So we're saying I equals 1. Then x1 bar is equal to 0.03125. Okay, and then f of x1 bar is equal to, here's where we need our, we need a calculator for sure, because we need to compute sine of xi bar squared. Sine of x1 bar squared. So that's going to be sine of 0.03125 squared, which is equal to let's see here. We've got to make sure that what we have is in the, we've got to, I'm going to pause the video because I want to make sure that I am inputting, this is radians. So I got to make sure that what I input into my calculator is radians and it's not, and my calculator isn't set to degree mode. So what I'm going to do is I'm going to stop now and I'm going to put up the result of this table. Okay, I'm going to show you how to find the first few midpoints. Once you find the midpoints, it's easier just to plug them, right? Like this is the difficult part, or the more complicated part is figuring out your midpoints. Once you know your midpoints, you just have to plug them into your function to get this column over here. Okay, so let's just go through how to find the midpoints. Okay, so here's the deal. So I'm going to show you a picture here again, an overview. Now here's 0, and we said our first endpoint, the endpoint of our first subinterval is 0.0625, right? Now what is our second subinterval? It's going to be twice whatever that is, so 0.125, right? Now, we found our first subinterval, midpoint is 0.03125. And what we can do to get the second subinterval is to just add the width, 0.0625, right? Because if you add the width, it's going to take you, it's like you're hopping from midpoint to midpoint. You're hopping between midpoints. Just like if you start at the end point and you go the width of each rectangle, you're hopping from endpoint to endpoint. Okay, so to get x2 bar, all we have to do is add 0.0625, which is the width of each rectangle. We just need to add that to the midpoint of the first subinterval. So we'll get 573,900. Okay, and then how are we going to get the I3 or x3 bar? We're just going to add 0.0625 to 0.09375. Okay, and then whatever that is, 5, 12, 6, 15. Okay, so then over here, f of x2 bar is going to be sine of 0.09375 squared, and this is going to be f of x3 bar is going to be sine of 0.15625 quantity squared. Okay, and then once you get all of these, right, you get your chart of your xi bars. You're going to just add them up and multiply it by 0.0625, and that's how you get your
It's 2045.
sorry, that's how you get m sub 8.